Here another thing that I want you to know is offshore wind farm and onshore wind farm. This one offshore is built on bodies of water ranging from oceans to large lakes, and mostly on, as you can see in this photo, they are installed on the lake. In which they can harness the surrounding wind in the lake. Onshore means a wind farm located on land. This one, like land. On their own land, we can say onshore. Wind turbine use the natural movement of the surrounding air to generate power. They use the air, right? The surrounding air, wind. They use the surrounding wind, especially that comes from the ocean. So we have offshore wind farm and onshore wind farm. I think this one is clear, guys. I hope so. So let's go into an interesting topic, which is forces on wind turbine blades. We do have different kinds of forces on wind turbines. So let's see them. What are they? And I want you to tell you that these are, when you design a turbine, these are the most interesting and important thing to consider. These forces, these wind turbine forces. The first one is lift force, and then we have drag force, we have centrifugal force, we have gravitational force. Just out of curiosity, don't be confused, okay? Just let me go through this lesson and let me make it clear for you. We're not going to see the calculations or something, but I will tell you what kind of force is it and how it is affecting the wind turbine. So you can go later for the calculation part. So let's see the drag force. The first one is the drag force on wind turbine. The drag force on wind turbine. We have drag force are caused by the air molecules that hit the surface of the blade facing the wind. Here we have the airfoil drag force, right? We have here airflow, right? We have this one is the angle of attack, lift force, center of lift, and drag force. So to make it clear, you have this thing, right? These are the rotor, and here we have the main shaft, right? So a major component of the drag force acts in the direction that is parallel to the main shaft of the rotor. When the wind is right here, the rate will affect to the main shaft, this one. If you guys are familiar with cantilever beam, when you were studying the mechanics course, this is a beam, right? This is, let's say this beam is fixed here, and let's say if a load of 20 kilonewton, let's say this one is 20 kilonewton. So this beam is only, this is a beam. So this beam is only supported here, right? Let's say this is fixed support, yeah? So there is a load applied here. So we call this effect, let's say if it's going to bend like this, we call this one cantilever beam, right? A beam that's only supported at one edge and there is no support here. So if you apply a force, there's gonna be like this, right? So we call it cantilever beam. So the same thing happens here. The drag force mainly affects us here. Yeah, right here. And you can see this one is the blade, so it mainly affects direction that is parallel to the main shaft of the rotor. Parallel to the main shaft of the rotor. This one. Yeah? A major component of the drag force acts in the direction that is parallel to the main shaft of the rotor. Parallel to the main shaft of the rotor. This one is the main shaft, so this one is the force which is acting here. We call it drag force.